Welcome back everyone. So in the last video we were talking about the error analysis of Newton Raphson method, but there was some mathematical confusion in that video. So I could not explain that to you properly, so I went back and revised my notes, and now I have come up with a better explanation of Newton Raphson error analysis so that you can understand it properly. So let us start with that error analysis part. So now we are doing the Newton Raphson method error analysis. So Taylor series approximation I am going to write. So my Taylor series is that f at xi plus 1 is nothing but f at xi plus f prime xi plus 1 minus xi plus f double prime xi upon factorial to xi plus 1 minus xi to the power 2, and we have higher order terms. So now I am approximating it up to the this term only, this first order term only. So I am saying that the first order approximation will be f of xi plus 1 is nothing but f of xi plus f prime xi plus 1 minus xi to the power, xi to the power 1, this is 1 only, plus f double prime chi upon factorial to xi plus 1 minus xi to the power 2. So all the higher order terms are approximated with this chi, where this chi is in between xi plus 1 and xi. Now this is my equation number 1. Now I want you to note down this equation number 1. So I will rewrite it in the next slide. So we have this f of xi plus 1, that is nothing but f of xi plus f prime xi plus 1 minus xi plus f double prime chi upon factorial to xi plus 1 minus xi to the power 2. Now I am saying that if xi plus 1 is xr, that is the true root, so I can say that f of xi plus 1 is nothing but 0. So I have this equation, that is 0 equal to f of xi plus f prime xi xr minus xi plus f double prime chi upon factorial to xr minus xi to the power 2. Now remember this is my equation number 2, where this was my equation number 1. So I will rewrite this equation number 2 in the next slide. So my equation number 2 was that 0 equal to f of xi plus f prime xi xr minus xi plus f double prime chi upon factorial to xr minus xi to the power 2. So this is my equation number 2. Now from the equation number 1 in Newton Raphson method, we say that this is what I am getting from equation number 1. F of xi plus 1 is closely equal to f of xi plus f prime xi xi plus 1 minus xi. Now in Newton Raphson method, we say that at each iteration I have achieved the solution. So at each iteration, basically we are approximating the curve with this line, and then we are saying that wherever this line hits the x-axis, that is my root. But actually this is not the root, this is the root of the corresponding iteration. Then we will check for the error and see whether my solution has converged. If it has converged, then it will be the true root or close to the true root. But in Newton Raphson method, if you remember that let us say this was my curve, and what I did, I approximated this curve with this line, that is the tangent at the guessed value. This is the guessed value, and then I have approximated this curve with this line for this particular iteration, and I say that wherever this line hits the curve for this particular iteration, that is the root of this actual function. So we are basically approximating this curve with this line in this particular iteration, and saying that wherever this line hits the curve, that is the root of this line. So that's what I mean. So that means that within each iteration f of xi plus 1 will be 0. So we have this 0 equal to f of xi plus f prime xi plus 1 minus xi. Now I want to note down these two equations, equation 2 and equation number 3. Now if I subtract this equation 3 out of this equation 2, then this term is 0, so it will be 0 only. F of xi will cancel out, then we will have this f prime xi, and that will come out as common, and we will have xr minus xi plus 1, and then we will have this error part. So I am writing that down in the next slide. So I have this 0 equal to 0 plus f prime xi xr minus xi plus 1 plus f double prime chi upon factorial to xr minus xi to the power 2. Now my true error is defined as xr minus xi barabar e true error at I plus 1. So that will make that f prime xi e at I plus 1 is nothing but minus f double prime chi upon factorial to e at I to the power 2. So that essentially makes it as f ei plus 1 equal to minus f double prime chi upon factorial to f double prime xi ei to the power 2. And if we are close to the root, to the true root, then xi equal to chi equal to xr, that is my true root. So essentially this will make ei plus 1 is nothing but f double prime xr upon factorial to f prime xr ei to the power 2. So this is my expression. Now I am giving you this. So essentially we are saying that error is roughly proportional to the square of the previous error. So what does this expression says? That we have this expression that e, that is the true error at I plus 1 iteration, is nothing but minus f prime xr upon factorial to f prime xr, this is double prime, and e true error at ith iteration to the power 2. So we are saying that error is roughly proportional to the square of the previous error, or in other words we are saying that number of correct decimal places approximately doubles with each iteration in Newton Raphson method, and this kind of convergence is called quadratic convergence. Quadratic convergence. So this is about the error analysis of Newton Raphson method. In the next video we will talk about second method, and then we will continue in the next video. So I hope you understood this very clearly. I'm going to finish this video here only because there is a turbulence from outside. Somebody is talking outside. Thank you.